Hello, let's continue with our learning of Zig using ziglings. If this is the first video you're looking on my channel, um, basically I'm trying to learn system programming with Zig, and I'm following this wonderful course called Ziglings that you can find. I'll leave the links in the description. But I'm trying to follow these courses, these exercises, so I can get a fundamental understanding of the Zig programming language. Let's continue with the next exercise. Um, okay, let me pull up the repo. And we completed the first two exercises, which were very simple in the previous video. I'll go with the third one. Um, and I believe it's about assigning values to constants and variables. Let's see. It says, it seems we got a little carried away by making everything const of unsigned integer of 8 bits. Const means the values cannot change, which makes sense. U is unsigned and cannot store negative values, which also makes sense. And we have 8 bits in size, which makes sense. It's nice that it clearly represents that it's unsigned, it's integer, and 8 bits. That's pretty cool. Okay, and we'll say example. Foo cannot change, it is constant, and bar can change, it is a variable, which makes sense. We're defining foo as a constant, bar as a variable, so bar can be reassigned, but foo cannot be reassigned. Also, it indicates that since it's 8 bits, it stores everything from 0 to 255. Yeah, a total of 256 values can be held. And bar can be negative, and it has a smaller upper bound, but then that also means that it has a larger lower bound. So minus 128 to plus 127 because it's an integer. That makes sense. We're also seeing here that constant if U8 holds up to 255 values, where if it's in a 16-bit unsigned integer, it holds a significantly larger value, which also makes sense, which is pretty straightforward. I don't think that's unique to Zig. That's how it is in most languages. Let's see. You can do just about any combination of these that you can think of. U32 and integer 64 bit representation of a signed integer. Okay, that makes sense. So now we're seeing that there's an error in the program. Again, just looking at the name of the exercise assignment, it's most likely we're trying to reassign constants or something like that. But just let me just read the program and try to understand what's happening here. Okay, we're importing the standard library. We have a public main function. Again, these were the two issues from the previous two exercises. Okay, we're assigning a constant of 50 to an unsigned integer of 8 bits. And now we're adding 50 to 5. This is clearly incorrect because it's a constant, and now we're reassigning it here. That's a big giveaway. Also, we have a constant pi of unsigned integers, and a constant negative 11. Again, this is an unsigned integer, but now we have a sign which is a negative number, so this will also need to be changed. Okay, let's read the last line. There are no errors in the next line, just an explanation. Perhaps you noticed before that the print function takes 2 parameters. Now it will make more sense. The first parameter is a string. The string may contain placeholders, and the second parameter is an anonymous list literal. Okay, it's a list literal. That makes sense. For whatever reason, I don't know, it felt like a structure of some sort, but it makes sense that it's a string literal. I mean, it's a list literal. That kind of makes sense. We have whole bunch of placeholders that get replaced in order that they're written here. So the first one would be n, the next one would be pi, and the last one would be -11. That makes sense. Don't worry about this for now with the values to be printed. Okay, we'll probably have more explanation on how to define these, but I think I get the idea. Okay, before I make any changes, I'm going to try and run the program to see what errors we see. Let me move the exercises. Zig run. Okay, we have our first error here. It says cannot assign to a constant, which we identified. And in Zig, we use the var keyword. The var reserve word would indicate to the compiler that, hey, this we cannot guarantee the value at compile time, and this value can change dynamically in our code throughout the program. Okay, and let's just run this, and then we'll come back and fix this one too. Let's see, Zig, let me clear the screen. I'm gonna run it again. Okay, now we have a second error. It says you're trying to assign an unsigned integer of 8 bits, this huge value. And I think an unsigned integer, I mean, we can see it right here. It stores any value from 0 to 255. I believe even if we go to unsigned of, let's see if I can drill unsigned integer type, 16 would maybe satisfy, maybe not. I don't think so. Let's just go straight to 32 bits. And I believe this should fix the problem. Yep, looks like we solved the issue that we were running into here. And let's see. The next error is, again, it's an unsigned integer of 8 bits, but we're trying to assign here. Let me just change this to signed integer of 8. 8 bits is sufficient because, again, if you see, I think we can store any number from -128 to +127, and -11 comfortably falls in that range. Let me try running it again. Perfect. Now we have the print statement working. We know that the program was built successfully. That's nice. I think we got a good idea of, at least I got a good idea of how assignments work, and I also like that it had examples of signed and unsigned values. Let's go to the next exercise. Arrays. Okay, let's learn some array basics. Arrays are declared with variable name, the type annotation here. We're assigning it with, okay, this seems like it's the size, 3 elements. The data type, again, this would be a homogeneous collection of items, so all the items in this collection would be of the same type. Makes sense. And we have 3 different values here. That's good, that's helpful. Okay, and it also says when Zig can infer the size of an array, you can use the underscore for the size. You can also let Zig infer the type of the values so that the declaration is much less verbose. Okay, that makes sense. So we can do this, or I'm wondering we can also ignore, oh, okay, I see. We can ignore this portion as well, since we're already indicating the type of the collection here. And plus we can ignore the size because, again, we're declaring and assigning it at the same time. So essentially the compiler can infer the size just by looking at the number of items we're assigning. That makes perfect sense. Also, I feel like most people who are even watching this would know, but in case you don't, it's almost a convention in a lot of languages where we use the underscore when we're trying to like, discard a value returned by a function, or we're just it's more like a placeholder. But it makes sense here that it's actually something that the compiler looks for. Okay, let's see. Getting the values of arrays is, again, this is pretty straightforward. We have three elements here, and an arrays, as most people would know, is uses zero-based indexing. So this is the first element is at index 0, the second element is at index 1, and the third element is at index 2. So foo of 2 would return this value. Set values of an array using array of index notation. This also makes sense. So we're going ahead to 0, 1, and 2, and we're going to replace 5, 4, 2, 3 with 16. And we can do this because the array is declared and initialized as a variable that allows us to modify the contents in this collection. Okay, getting the length of the array. Okay, it has looks like Zig arrays have properties called length, and it's JavaScript also has something similar. I know C# has something like that where we can use the length property in arrays, and if it's like a list in C#, which is dynamically allocated, I believe we can use count. Yeah, most programming languages have something similar to this where as we add items or remove items from the collection, I believe a property is maintained indicating the size of the collection. Okay, let me see. So we have the standard library again, which again, this seems to be pretty straightforward as we've seen in the previous three exercises. We have a public main function, the entry pointer to our program. Let's see, we have the first problem. The const is going to cause problems later. Can you see what it is? How do we fix it? Okay, so we're declaring a constant array here of unsigned integers of 8 bits, and we're inferring the size. Now, clearly from the very next line, in line 34, we see that we're trying to reassign this the first value to 2. This would obviously fail because, again, constant, you cannot modify the value held by this by some primes. Let's just run it just to see how, because it's my first time learning Zig. I want to familiarize myself with how the compiler throws errors. Let's see. Oh, okay. First thing it's saying is expected type expression, but found. Oh, I wonder what this is. Line 43. Oh, never mind. Okay, it's already going here. This is a little surprising. I was expecting it to throw an error here because we're taking a constant value and assigning it, and we're reassigning one of the items in the collection. I thought that is what the problem was suggesting, but this is interesting that it didn't throw an error here, but it's throwing one here, which I guess it makes sense because the syntax, this is a syntax error, and this is it a logical error? No, this is also, yeah, this is not a syntax error because I wonder if it falls under the category of logical error. Usually logical errors are something like we're trying to divide it by 0 or something. I know it's an error for sure because we're breaking the rules of the language, so I would assume it's syntax. Maybe I need to read up a little bit more on the class of the error, but that's nice. I mean, we're learning through systems programming, so that's a good thing to think about. Let's see. Let's ignore this for now. We know something is wrong here, obviously because it's saying there's a problem, and reading it, it seems like this needs to be changed into a variable, but we'll ignore it now. I want to see the compiler throw an error and then fix it so we understand it better. Let's just go to this. We'll see individual values can also be accessed with the bracket notation. Yes, makes sense. If we can reassign it, we can also access it. Makes perfect sense. Let's look at this portion of the problem. It says, looks like we need to complete this expression. Use the example above to set fourth to the fourth element of the sum primes array. Okay, fourth, we have a bunch of element. What is the fourth element? It's this is the first, second, third, and fourth. The value should be 7, but the index is 3. Because again, arrays use zero-based indexes. Perfect. Let's go to the next problem. Again, since we fixed this, let me just run it and see what happens. I believe the error will now go down here. And I believe after these obvious syntax issues are fixed, the error will come back here and says, hey, you're breaking the rule. Let me run. Perfect. Yes, looks like we fixed the issue here. And we'll go to problem 3. And it's pretty straightforward. We're trying to find the length. We don't have to loop through the collection and increment a counter. We can directly call the length property, which was explained to us here. That's pretty cool. Okay, let me run this. And our expectation now is this is going to break. Hopefully it does break and I haven't got this wrong. Let me clear the screen. Perfect. Okay. I want to understand this more and I'll research a bit more about it. But I think it makes sense. It caught these two issues first because it was syntax issues, and it was like, again, we can't even parse the file if something is so obviously wrong, and there's question marks which are used incorrectly. And now that it caught those errors, it circled back here and to see that, hey, this doesn't logically make sense because you said it's a constant and now you're saying you're reassigning it's a value. That kind of makes sense. Caught the syntax errors first, came back, it looks at the logical error and it's saying, yep, you're breaking the rules here, you're saying it's a constant, you're trying to reassign, something's wrong. And the error is clearly saying cannot assign to constant. Let's change this to a variable, and I believe this will fix it. Perfect. Now we have our debug statement printing the values. It says the first element is 2, which we know from here, which we just reassigned, so this would have been changed to 2. And the fourth element, so 1, 2, 3, fourth element is 7. And the length of the collection, again, there's 4 here and there's 4 here. The length of the collection is 8. That makes sense. That was a good example. Usually I want to keep these videos no more than 30 minutes, and I think we're 18 minutes in. So let's just try another example, try to get that done in the next 10 minutes. But that was a very good exercise. Let's see. Zig has one array operator. You can use plus plus to concatenate two arrays. Oh, okay. This is new. I have seen the plus plus operator, but that's only in collection in reference to let's see. Let's see, new text file. Yeah, I've seen this in C++ and even in C# to an extent where say you have a variable I, we'll assign it to 0, and we can do I++, and we can either prefix it or postfix it, um, and essentially this will increase it to 1, um, and this will basically use 0 and then increment it, whereas this will increment it first and then use it. um, I have never seen it be used in the context of arrays, so this is new, and this is pretty cool shorthand to merge to arrays. Okay, another interesting thing is it looks like we're taking the first array, concatenating it with a second array, and this will be a new array. That is also pretty good. I know in some languages, when we do a concat like A concats B, then we will be modifying A um, with elements of A plus the elements of B. But I like that in Zig, it's a little bit more pure, wherein if you're performing this operation, a new constant collection is created. Um, um, okay, and along with that, we're also throwing in another array, which makes sense. These variables were never really needed. We could directly use these here. I understand it. That makes sense. Note that the plus plus operator only operates on arrays while your program is being compiled. Oh, okay, that's interesting. This special time is known in Zig parlance. Is that how it's pronounced? How do I pronounce this word? Parlance. Let me see. Refers to a particular manner of speaking, often characterized by specific vocabulary.
Parlance.
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 Parlance. Okay. That's a Zig specific terminology. That's cool. Called as comp time. Yeah, here's where we see um, um, the word comp time be reused again. I think we saw it somewhere in exercise 2. Was it 2 or was it 1? Yeah, here, compile time. Okay, that's interesting. We also saw it in the Stack Overflow answer once, but let me pull this back. Okay, that makes sense. Plus plus can only be used at comp time, but it cannot be used at runtime. Let's see what that means. I believe the example will probably shed more light into it. Okay, let's go to the first problem. So we have two arrays here of integers, and we're trying to find delete. Please set this array concatenating the two arrays above. It should result in 1337. Okay, that means we'll do. Oh, that's pretty funny, because it has the name split into two. Okay, le plus plus et lead. Okay, pretty straightforward. Let's go to problem 2. Please set this array using repetition. It should result in 1001100110001. I believe we're just doing this. But since we see it, okay, let's actually take the brute force approach first. We're trying to do something like this, right? We want that to be the end result. However, since it's clearly saying it's repetition. Also, if you think about it, we see when I highlighted this, there are 3 different highlights. Basically, this is showing up 3 times. Can we repeat on this? Probably not. Let's just repeat on this to make things easier. We'll say this. Not that it matters, but I think it's just fun to use the new operator we just learned. I think the resultant will still be the same. We have three, we have four threes, we have 12 elements. We can see that dynamically. Um, um, this is again VS Code, the LSP showing me how many elements are here, which is pretty neat. Perfect. Now we understand that. Um, and we have a bit pattern. Oh, okay, never mind. Seems like all it was asking me to do was this bit pattern unit, and now it's creating the actual bit pattern using the unit and saying the total length will be the length of the unit multiplied by 3, which makes sense if you see it here. I was trying to add it 3 times. This is way more fluent. And we're saying yes, it's unsigned integers. We're defining the length and the type, and we're saying at bitcast, let's see what this is, converts the value of one type to another type. The return type is the inferred result. Okay, there's some type conversion happening here, and we're doing ASS performs type coercion. This type is allowed when the conversion is unambiguous and safe, and is the preferred way to convert between types when it's safe. Okay, so bitcast is converting a value from one type to another. So it's converting this. Where does this end? Okay, it's converting this whole thing into, I believe, this type, since we have declared it here. I understand bitcast. I think I understand the at as, where so we have comp time t type, and there's an expression. The first one is the type, second one is the expression. I see. So similar to how we have effectively this equates to 12, an unsigned integer array of 12 items. This is a compile time type. I believe based on the examples previously and now, types are a compile time thing in Zig, and a dead giveaway is also the use of comp time keyword here. Comp time t is of type t. We know from the previous examples, type is always comp time. It's a comp time only primitive. Okay, that makes sense. So we have a type coercion here. This is actually, we're defining the type and we're defining the expression. We have the bit pattern unit here, which makes sense. I don't know what at splat is. Let's see what that is. Produces an array or vector where each element is the value scalar. Okay, and scalar is of any type, the return type, and thus the length of the vector is inferred. I see. Let me see. Okay, we're trying to say we want bit pattern's length here, which is 4 elements, and we'll say, hey, by the way, we want an array of 3 elements where each of the element is 4 element array. Okay, kinda makes sense. And splat produces an array where element is the value scalar, the return type, and thus the length of the vector is inferred. I see. And we have this at as to perform the type coercion, convert between types, convert this to that. Okay, this is creating Okay, I believe splat. Okay, I might have to look this up, but I think here's what's happening. Uh, Let me create a couple of. I believe at splat bit pattern unit essentially takes whatever we're passing in as the unit, which is one. I'm just gonna give it proper type declarations here, so it's easy for us to grasp, easy for me to grasp at least, because I'm trying to learn this. Okay, we have splat, we have the bit pattern unit, and this is essentially we're passing in any type can be passed in, and it's going to produce an array. It conforms to a type. Okay, okay. I wonder if this could have been broken down into something like const bit pattern in progress 12 u8 bit pattern 12 u8. Oh, that's exactly what's happening here. Never mind. Actually, let me see. 3. Oh, is this even the right way to write? I'm just gonna give it a try just to see what's happening here. I do not know if this is valid Zig syntax, but I'm just trying to break down the problem to try and understand. It's saying it's going to create a 3 item collection where each item is of this particular type. So I wonder if the output of this is something like output of splat bit pattern unit. It can be done like this. I wonder if that's what it's trying to do, which would make sense, but I could be completely wrong. But essentially, how would this look in a representation? I wonder if it's going to look like 1 0 0 1 1 0 0 1 1 0 0 1. So I wonder again. I cannot. I'm not. I don't know for sure, and I have to look this up. But I'm just trying to break it down into the closest thing that I can sort of simplify it to, so that I can understand. I know simplifying things sometimes we lose context, but let's see. But this would sort of make sense instead of, because that's what's happening here, where when we're creating a type and we're assigning it. In this case, since it's an intermediate step, this would make sense as to why we need the type coercion operator here, and why we have splat here, because what splat is trying to do is it's going to take whatever we give it, which is a scalar value. I mean, it's any type value. I don't know why it's called scalar exactly, but let it be whatever it is. And it's going to say whatever is passed in, I will go and make it match this type, and I will repeat it up until we get this particular until we satisfy this particular type definition. So I know in, let's because in we do have something similar in a lot of other languages as well. I believe in Python we can do something like 0 into 3, right? Array, I'll say array of nums. I believe this will essentially create something like 0 comma 0 comma 0. I believe so. I believe Zig is trying to do something like that here. So we have splat. Again, reading this, it seems like it's going to return a type, and the length of the vector is inferred, and it produces an array of vector which each element is scalar. Essentially, it's something that says, hey, repeat this as many times as needed, which is defined by the type. And the type definition or the type coercion will work fine because there's no risk here. It's just going from one element of unsigned integers into this particular thing, which makes perfect sense. I get it now. Um, yep. And now why do we need this? Bitcast. Okay. Okay. This is probably needed because we have it in this format where there is an array of arrays, and now we want it to be flattened, right? I think we want this now. When we say bitcast, I believe it takes whatever we add here and it removes the nested structure and flattens it out, right? Which kind of makes sense. So we're defining the pattern and we're going and we were defining the pattern unit, and we're then creating this big pattern, which also makes sense. Do we have any other problems? No, we don't. Let's just run this. I know we probably should have run it and seen the error before, but that's fine. I'll try to do that at the next exercises. Let me just see what happens here. Okay, everything seems to work, and it says that, oh, the explanations were right. Okay, wait, all the problems, let's see the results. We could print these arrays with 0, 1, but let's have a little preview of Zig. There's a for loop. Okay, perfect. We'll come to this a little later. Essentially, the way we're defining, let's just ignore this for now because there's no problem here. We'll circle back to this, but we know this works. I just want to try and break it down into smaller pieces to see if my understanding was correct. So let me say my bit pattern unit is 0, 0, 1, which is same as what we have there. As it's saying that I've not used it, so why do we, yeah, unused, that's fine. I'm gonna say my bit pattern part bit pattern step 1, and let's define it like this. We'll say 3. We'll say my bit pattern dot length, and we'll say of unsigned integers. Is this correct? Yes, that works. Okay. And now now I believe I can skip this operator. So I'm just gonna do splat repeat bit pattern unit. Will that work? Yes, that looks like it works. Okay, so we were on the right track. Now let me try to create the final pattern. My bit pattern step 2, and I'm gonna say do something similar. Bit pattern wait, why is it 3 times the bit pattern unit? Oh, okay, that makes sense, because 4 into 3 is what we're aiming for. Or actually that's how it is. bit pattern unit. Let me just directly write 12 in this case. Actually, never mind. Length into 3, which is fine. And we'll say, now I want you to cast this. And we'll just pass in this. Will that work? Expected type express. Oh, my bad. You unsigned integer of 8 bits. Perfect. Now, similar to how we were printing the bit pattern, I'm just gonna call. We'll circle back to for loops just to see if this thing even works. Let me just try something. My bit pattern step 2. All right, let's run it. Yes. Initially, this is what was printed by the original problem, and we can see that our approach where we broke it down into smaller pieces, so we did actually understand it correctly, where splat is just repeating whatever was passed in, and it repeats it n number of times. That n is defined by the type that it's being assigned to, and in this case, since we're not assigning it to a different variable, we're just using at as, which is type coordinate, saying, hey, by the way, I don't want you to assign it to any space, any variable, but I'm going to take this pattern, you enlarge it, and I'm going to give you the definitions of how to enlarge it here. And now that we've repeated it n times, in this case, since we had a collection already, an array already, let me use Zig terminology. Now we'll say, by the way, we need to flatten this out. And so how can we flatten a nested array into just an array? This will work fine because array again is a collection of elements of the same type. Since we know all the elements will be of the same exact type, flattening it out is not a risky operation. In fact, it's not going to fail, which makes sense why it was sort of straightforward to convert it. And I'm sure there's some edge cases and catches. At least from different languages, there's always been hidden magic. I believe Zig's whole spiel is that it will not have this kind of hidden behaviors, but let's see, as we use it, we'll see. Maybe there isn't any hidden behavior, or if there is, there's probably good reason. But I'm glad we broke it. I'm glad I broke it down so I can understand this. And it's a yep. The syntax is similar to other languages. The approach is more, I would say, low level. It's not. You sort of see exactly what you're trying to do here. But I believe if I was writing C#, and not that it's wrong, it would have been more fluent and more higher level, and where I didn't have to worry about types all that much, and I would just say, hey, repeat, and just convert .to list or flatten or whatever. But that kind of makes sense. Okay, let's take a sneak peek of the array as well. Okay, that's all the problems. Okay, and this is how they're printing the values out one at a time, and the syntax is for item array, and this item, do something with the item. Okay, this is probably very similar to a for each loop in other languages. If I were to write C#, I believe we would do, or even JavaScript for it would be something like this: var each number in numList, do something. But yeah, this seems very similar to those things. Okay, we're doing for we're saying, oh, this is a string. Okay, okay. A string can be passed, and each of the string, each item is taken into n, and we're printing it. And n is defined as an unsigned integer of 8 bits. And I remember. Oh, never mind. Okay, it's not a string. My bad. It is still an array of numbers, and we're doing for each item in this collection. Let's define the item here, and we're gonna print it out one at a time. Okay, that kind of makes sense. And I'm sure there'll be exercises here. I can see it here already with all the conditional statements as well as the um, iteration constructs. We'll get to it. I believe we slightly exceeded 30 minutes, but this was a very fun exercise. Again, if um, anybody wants to learn Zig, highly recommend Chris Bosch's Ziglings. So far, so good. It's been a really good introduction to Zig and by extension to systems programming. That's it from me. See you all in another video. Thank you.